My dear viewers, so today we will going to study very interesting topic, that is functions in C. So let's start. So how function is defined? The function is defined as self-contained subprogram that is meant to do some specific well-defined task. A C program consists of one or more functions. So if a program has only one function, then it must be a main function. So let me give you one example. So the function is self-contained subprogram that is meant to do some specific task. For example, let's say suppose there is a one car is having different system. For example, braking system is there, then for starting and stopping the car there is on and off button is there, then steering is there, then accelerator is there, right? So if I tell you to start a car, what you will do? You will use the start button, right? To stop the car, stop button. Then to turn the car, you will use what? Steering. To stop, to brake the car, you will use the braking system, right? So here every component is having their specific task, right? Every component is assigned some specific task. We are not performing all the tasks by only one single component. Every single component is having different tasks. This is called as what? Modularization. Okay, see tomorrow if suppose car is not starting, right? So where you will go and where you will find the faults? Whether you will go and check the braking system? Okay, you will not. What you will do, you will go and you will check in the on and off button, right? Whether why the car is not starting. If let's say the braking system is not working tomorrow, then you will not go and you will not check the steering, right? Where you will try to find out the faults? You will try to find out the faults in the steering, in the braking system, right? Because braking system is not working. So if the tomorrow there is a problem in one part, you will not going to check the other parts, right? You can focus on one particular part only. So this is what, when the error will happen in one particular function, you will not go and search in other function, right? You will try to find out the errors in that function only. So this is what, for debugging also it becomes very easier. Clear? First of all, the entire complex car is divided into different components or functions, right? Where every component is performing their separate functions. In the similar way here also, suppose there is a large software is there or a very complex problem is there, what we normally do, we divide that complex problem into number of sub components, sub programs, right? Where each part of the subprogram will perform certain specific tasks. And this is how we do the modularization in the big problem. We divide the big problem into number of components or number of subprograms, and then we do what? This is called as divide and conquer rule, right? We divide this problem task into smaller ones, and then we try to develop the entire system. So that's why, and whenever a function is there, it is self-contained. Okay, it is self-contained subprogram. It can perform the specific task. For example, the braking system itself can perform its one particular task. Okay, similarly the steering system will perform some specific task. In the similar way, in the language also, if there is any function is there, it will perform some specific task. That's why it is defined as a function is self-contained subprogram that is meant to do some specific well-defined task. And this is also useful also many a times. For example, let's say suppose I am a I am a doctor, right? And the patients will come to me, right, for their problems. Clear? But let's say tomorrow if somebody is having problem in the car, right? So that person will not come to me and bring his car to resolve his problem. Where he will go? He will go to the mechanic, right? So that's why there are, so the different professions are there, right? One person can't be strong enough in all the profession. Clear? So for one particular or specific task, I'll go to that particular person, and then I'll let my job done. So for everything there is a particular task is assigned, right? Specific task is there. Okay. And one more thing you remember, that in C programs, at least there will be one function always present, that is the main function, right? So if user has not written any other function, or he has not used any library function, then there will be at least one function will be present. That is what? That is the main function. Let's go to the next slide. So advantage of using the function, let's go one by one. Some of the advantages I have already explained. So the first advantage is what? The divide and conquer technique. So in divide and conquer technique, here how it is utilized, we divide what? The big problem into smaller ones, and no, for every smaller problems we write one function, and then we finally collaborate into one big software, right? And this is how we solve the problems. This is called as the modularization. Bigger problems divided into simple modules, and then finally we accumulate all the modules together. Okay, then next advantage is what? Whenever some specific code is to be used more than once at different places in the program, the use of functions avoids repetition of the code. For example, suppose I have written one big problem, okay, one big program. In that addition function I have written, one user defined function I implemented, that is addition function. And if suppose that addition function I have to use at 50 different places, right? So I will not write the code of addition function at each and every place again and again. Instead of that, what I'll do, I'll simply call that function, that's it. Okay, so I'll write the function once, and I can utilize that function at multiple places. I don't have to repeat the same code again and again. So it will basically save my number of lines also, right? And it will avoid it will, it will not take my time also, right? It will save my time. So the next third point is what? The program becomes easily understandable, modifiable, and easy to debug and test. I told you how it becomes easy for debugging and testing, right? If tomorrow some problem is there in the addition function, I'll not go and search the problem inside the subtraction function, okay? Because the problem or error is there in the addition function. So I'll basically try to concentrate on that addition function only. So this is how it becomes very easy for modifying, right? Or to debug or testing purposes. So it becomes simple to write the program and understand what work is done by each part of the program. And the last is the function can be stored in a library, and this is how we can achieve the reusability. For example, suppose I can write my own function and I can store in C library, and whenever I need to whenever I need to have same kind of functionality, I can call that function from the library, and wherever, or not, it's not only me but anybody in entire world, if they want, they can use my library and they can call that particular function and use that multiple times. So we can store our functions, we can write once, we can store our function in the library, and we can use it multiple times. Wherever anybody wants, they can utilize from the library. So this is the beauty of the functions. So again listen all these points. The advantages of function. The first one is what? Divide and conquer technique, right? So in this particular technique, what we do, we normally take a bigger problem, we divide into number of sub problems, right? And for every sub problems or smaller problems, we write a function, or we can say that the bigger module we divide into simpler modules, okay, smaller modules, and then finally for every module we write the functions, and then at the end what we do, we collaborate everything into one entire software. So this is called as what? Modularization. Clear? And this technique is what? Divide and conquer technique, and it is implemented with the help of function only in C. The next point is what? Whenever we write any function, right, and if it's required multiple places, right, for example at 50 places we require the same functionality, we will simply call that particular function. We don't have to write the code of that function again and again, so we will avoid the repetition of writing the code. Second thing, it will save our time also, it will save the number of lines. The third point is what? It becomes very easy to understand, modify, or debug and testing. I told you why it becomes very easy for debugging and testing. And the last point, we can store our function inside the library, and whenever we require, we can use that particular library, we can call our function to perform that particular task. Next slide. Types of functions. So basically there are two types of functions available in C programs. One is the library functions and second is user defined functions. So library functions which are already given by it's inbuilt function which are already present, and second is user defined function which user will going to write, okay, according to his own convenience. Whatever function he wants, he can write those functions. Since the user will write the function, that's why the functions are called as what? User defined functions. And the functions which are already present, that are those functions are called as inbuilt function. So let's see first the library functions available in C. Right, there are lots of library functions available in C. Few are very popular and at multiple places you might have already used. For example, sqrt function to get the square root of any number, right? Power function which will give you the power of any number. Then scanf and printf, almost in every program you write the scanf and printf. These are all also what? Library function only. So scanf for taking the inputs and printf for displaying the output on the screen, right? So C provide the library functions for performing certain operations, and these functions are present in the C library and they are predefined. Okay, next. So this is an example of one library functions. So I've written one very simple code where I've declared two number double R and N. What I want to do over here is I'll ask one number from the user. So I am saying printf enter N, and I'm storing inside N that particular number. So what this function will do, it will simply calculate the square root of that particular number, and we are storing that square root inside our variable. So I am saying R equal to sqrt N, right? Now to use this particular function, you will have to include one library over here that is called as what? math.h. Clear? So I'll just modify that here. So you will have to include one math.h here, include math.h. So this library you will have to include. So for sqrt function, its definition is present inside this particular library. What is the job of sqrt function? To get the square root of any particular double number, right? And then simply we are displaying that particular number and its square root. So this sqrt function is already defined, nobody has written, it's already inbuilt function is available. Okay, we are simply using that function. So whenever we want to get the square root of any number, we can simply call this function. Only thing, we have to include this particular library. Similarly, we can use the power function to get the power of any number. Okay, let's go to the user defined function. So user defined functions are those functions which are created by the user. If user will going to create it or the programmer will create it, those functions are called as what? User defined functions, right? So there are few things which you should be aware of before going to this particular user defined function. Okay, and those things and those terms will keep on coming in each and every program. Okay, whenever I'll be discussing. So you must be aware of those things. For example, one is the formal definition. What do you mean by the formal definition? Second is what do you mean by function declaration, and third, what do you mean by function call? So with the help of simple example, I would like to tell you what do you mean by formal definition, function declaration, and function call. So let's see. So this is one simple example here. I have written one simple function example. Okay, so first thing I've written hash include study i.h. I've included standard input output header file. Then I've written this particular syntax, void, then space, show, and then this round bracket. Okay, there is a round bracket. So this round bracket denotes its function. For example, when this main function, you are already aware of this, right? So whenever we write void main, after that main we write this round bracket. So main is a function, right? That's why I told in the first slide, in every program at least one function will always be there, that is the main function. If no function is written over there, so one function will be always there, that will be a main function. So in a similar line we have written here what, a void show function. Okay, and this line is called as what, function declaration. So that means this function we will going to write somewhere. Okay, the definition of that function, the job of this function is what, to show something, right? The job of this function is to show something. And here we have just declared, we have told the compiler that there is some kind of function which will come later. Okay, and that function will going to write somewhere. Clear? So this is called as a function declaration or function prototype. Please remember, it's called as what, function declaration or function prototype. So what function prototypes gives us, function prototype will always tell you what is the return type of that function. So here return type is what, void. It can be here int, it can be float, char, whatever the return type you want to write. So that is what the type. Okay, what type of value it will going to return after the task is over of that particular function, which type of value it will going to return. So basically here my function is not returning anything. Okay, this my show function will not going to return anything. So that's why I have written here void. And then after that, what is the name of the function? So here the name of the function is show, and then whether this function is taking any parameters or any arguments inside this function. So here my function is not taking any arguments or parameters inside the function. So always remember, your function prototype will give you three things. First, what is the return type? Okay, what is the return type? Second, what is the name of the function? And third, what are different types of parameters are there inside the function. So this is called a function declaration or function prototype. Then in the main function, what I have written, so execution will start from the main function, and in the main function I have written, I simply call that function show. Clear? So this is called as a function call. So how to call any particular function? Just write its name, and then you will be able to call that function. When this line will be executed, the execution will go directly over here, void show. Now in void show, here I have implemented the body of the function. Okay, how this function will perform the task, that part I have implemented over here. So this is called as a function definition or function implementation. Okay, this part is called as function definition or function implementation. So there are always three parts associated with the function. One is the function declaration, that is how that function looks. Then the second is how that function is called, right? So here this is how we have called the function. And third, how that function will behave, right? So what is the definition of that particular function, how it is implemented? So that implementation is over here. So please try to remember this. What do you mean by function declaration or function prototype? What is the function call? And third, what is the function definition or implementation? Clear? So let's go to the next slide. Now here I've written the same program, but there is a slight difference. If we try to compare with this particular slide. Here I have written the function declaration, then void main, and then I have written the function, right? But in this particular slide I have directly written the function, I have not declared that function. So this is also one of the way by which we can write the function program. So you can write that function above the main, or you can write the function after the main. So here in the first slide I have written the function after the main, and in the second slide I have written the function before the main. So if you are writing the function before the main, that is the function definition. If you are writing before the main, then this is not the function prototype. Okay. This is not the function prototype. This is your function definition. Okay, and yeah, this one is function declaration or function prototype. So remember this, by two way you can write the function program. One is you can write the function no, before you can write the function after main, and you can write the function before main. So if you are writing a function after main, so first main is coming, then you are writing the body of this particular function, then you must write the function declaration or function prototype. It is required, because otherwise compiler will give you error that you are trying to call the function inside the main, but where is that function, where is that function present, okay, how it is look. So you need to tell the compiler in advance that how that particular function looks, and that function will come somewhere down the below. So that's why if you are implementing the function after main, then you must provide the function declaration. But if you are writing function, if you are writing the function before main, then no need to write the function prototype. For example, in this one, it's not required. Okay, here we have written the function before main, so it's not required the function declaration, because the compiler can see it directly that that function is already declared over there. So whenever a function call is made, compiler knows that there is one function is present, so no need to write the function definition. So both the ways are proper. You can adopt any particular way, right? Which particular way I follow the first way. I always try to declare the function declaration. Why? Because if there are 1,000 lines of programs are there, so we don't have much time to go below and check which different functions are available. We can simply check over here only after the header file include and everything. Here only we can check the list of the functions which are available inside our program. So I feel this technique is much better. What I feel, but it's up to you. So you can implement in this way also. Okay. So the one more thing you will have to see whether the function is having certain arguments or not. So what do you mean by that? Let's say suppose there is one function, okay, add function, and job of that particular add function is what? To add two numbers, clear, and display it on the screen. So I have written one void add function, and inside this I have written int comma int. So I told you that the function prototype or function declaration job is what? To tell how that function looks. So what do you mean by how that function looks? What is its return type, what is the name of the function, and what are different types of parameters is being taken. So these are the different types of parameters inside the function parenthesis, whether there are different types of parameters are being taken by the function or not. So here two types of parameters are there. Two parameters are there of type integer and integer. Both the parameters are type integer and integer. These parameters are also called as arguments. Okay, these parameters are also called as arguments. So basically this particular what this tells, this function will going to take two integer numbers. Okay, this is the meaning of that particular syntax. So this function will going to take two numbers. So in the main, what I have done, I have declared two numbers, a equal to 5 and b equal to 7, and then I've called that function add a comma b, right? So I pass both the numbers because this function requires two integers to be passed. So I pass both the number. This is our function call. Okay, and here in the main, these parameters which we are passing, these are called as what? Actual parameters. So please remember, this is called as what? Actual parameters. So down the below here we are having the definition of that function, how that function will behave. So we have again written void add int a comma int b. So these two numbers, how this function will behave whenever the call will be made, the copy of both the values of a and b will be created, and that copy will be sent to these variables. So copy of a will be sent to a variable, and copy of b will be sent to b variable, right? So a and b will be having in turn 5 and 7. Clear? But these parameters of this particular implementation functions are called as what? Formal parameters. Here these parameters are called as what? Actual parameters, and these two parameters are called as what? Formal parameters. So inside this particular function, it's not it's just simply performing one simple task, that is the addition of both the numbers, and it's displaying on the screen. So sum equal to percentage a plus b, it's trying to display on the screen, right? So the job of this function is very simple, but my main motive was to explain you what we mean by not parameterized functions. Okay, and second thing, what do you mean by actual parameters and formal parameters? So remember, whenever the call is made from the main, okay, and whenever you are passing these actual parameters, then that is called as what? Actual parameters. And here these two parameters are placeholder for these two, okay, these two numbers, right? So these two will be taking the values from these two parameters. So these are called as what? Formal parameters. How the call will be made, whenever the compiler will reach here, it will see that there is a one function call it will have to make with two parameters of type integer comma integer. So the call will go over here, it will create the copies of these two values, duplicate copies. So 5 duplicate copies of 5 and 7 will be created, and it will be passed to these two variables, formal parameters, and then their value will be displayed. Okay, so based on this, there are different types of functions available. So for example, based on this, there are different types of functions available. For example, the first one is function with no arguments and no return value, right? So a function can have no arguments at all and it will not going to return any value. Second, a function with no arguments but it will try to return some value. Third, function with arguments and a return value. And fourth, functions with arguments and no return value, right? So it's all combination of whether the argument is present or the return value is there, or no arguments and return value, like that combination is present. Clear? So what is important thing is you must understand the function may have one argument, may have two arguments, three arguments, or it may not have even single arguments, right? So that is called a zero parameter function, a one parameter function, two parameter functions. But the idea is you must be clear with the difference of whether what do you mean by the function parameters or function arguments. Second thing, what do you mean by actual parameters, actual arguments, or formal parameters or formal arguments. Clear? Second thing, what do you mean by function definition, function declaration, and function call.